Hello, hi guys, can you hear me? Just write down in the chat if you can hear me. Okay. Uh, can you see my screen? Just write in the chat if you're able to see my screen. Okay. Okay, so we'll be discussing the first five and the F1 problem till E1 and F1. These would be the problems we would be discussing in the today's discussion. So you guys can write down how was the contest for you today. My voice is completely clear, right? It's not breaking or any issues with it. Just confirm once. Then we are going to start with the PCD now. Mhm. Are you talking about the voice that I need to improve or? Okay. I think the voice is clear, right? I was just confirming that, and then we are going to start with it. Okay, so let's start with the PCD. So, hi everyone, this is Abhinav, and today we're discussing post-contest discussion of the Codeforces Round 1012. So before starting with the discussion, let me just tell you a little bit about the newly introduced second version of the CP31 sheet. So in this new version, you can see that you have problems from rating of 800 up till 1900. There are 31 hand-picked problems from each rating, and in this new version you can also connect your Codeforces account to link your submissions from your original CF account into the seat, as well as you have this dedicated discussion session where you can discuss any of the problems, write some comments about it, have notes for it, and all. Also, you would find some video solutions which would be released which are in the process of being released in the TLE Eliminators YouTube channel. So for 800, 900, many of the problems have been released. Every week, 7 to 8 solutions would be released. So do check it out, and it's really a must try. So you will find the link to this sheet in the description of this live PCD. So now let's begin with our discussion. So the first problem is treasure hunt. Okay, so for this problem, let's read the problem statement. Little B and his friend K found a treasure map, and now they just need to dig up the treasure, which is buried at a depth of 8.5 meters. So they take turns digging. On the first day, little B digs. On the second day, little K digs. After each day they switch. So little b digs exactly x meters of soil, while little k digs exactly y meters of soil. They become curious about who will dig up the treasure first, meaning during whose day the total dug depth would exceed 8.5. So but they are too busy digging, so you have to help them find. Basically, you are just given as input three integers x, y, and a. What you need to find out is you are just given x, y, and a. So basically, there is some ground, and you have to dig uh, 8.5 meters. So like, let's say a is equal to 4. That means you would have to dig 4.5 meters. After digging that much, you will find the treasure here. So what happens first? The first person digs x meters. Okay, then the second person would dig y meters, and then again the first person would dig x meters, second person would dig y meters, and likewise it would proceed. You just need to find out which person would dig this treasure. Okay, which person would be able to find this treasure. Basically, after what step you are going, your total length of the uh, dug is going to exceed 8.5 meters. So that's what you need to find. If the first person is going to dig it, then you have to return yes. If the second person, then you have to return no. That's what the problem states you have to find out. So for example, 1 2 4. So if we take this test case where x is 1, y is 2, and a is 4, that means we have to dig 4.5 meters. Okay, so 4.5 meters is what we need to dig, and this can be done. So you need to dig 4.5 meters. So in the first step, the first person would dig 1 meter. Okay, then next step, second person would dig 2 meters. Then again first person would dig 1 meter. So we have reached 4 here, and then the second person would dig 2 more meters, and we'll reach 6. So after this step, we are crossing the 4.5 thing. So you would say that this second person was the person who dug the final uh, which found the treasure. So for the second person, you have to print yes for if little b digs up first. So here it was, you start with first day little b digs, on the second day little k digs. So you have to output no if little b digs it first, and yes otherwise. So here little b did not dig, so you have to output a yes. Okay, so for the second person you have to output yes, for the first person you have to output no. Okay, so here for this case, since second person using this 2, or you were able to dig, so you output a yes. Okay, so same way it's very simple. So I hope the problem statement is clear. Now how do you solve this? Basically, if you have an a, you have to dig 8.5 meters. Basically, you have to just exceed this a. So after which step your total sum of the values exceeds a, becomes strictly greater than a. That's what you need to find, because x and y are going to move in integers. So whenever you exceed a, you would reach a plus 1. So that would exceed 8.5, obviously. So when do you exceed a? So in each step you can say that first you dig x, then you dig plus y. So it becomes x plus y, then x plus y plus x, then x plus y plus x plus y. This way it is moving. So basically after every two steps you are digging x plus y, after every two steps you are digging x plus y. So whatever, if this a was 4 and this x plus y here in the first case was 1 plus 2 3, so basically after every two steps you will move in the multiples of 3 3 3. So first of all you can remove that common thing from it. So if in 4 you subtract 3, then you are left with 1. So 1, the remainder on dividing with 3, basically that would be the part which would decide who is going to dig that. So you can assume the problem as, instead of a, you can assume it as a modulo x plus y. The problem remains the same because after every x plus y steps, it again come back to the first person. So after x plus y steps, like you can assume that after every all the multiples of x plus y, the problem remains same. So basically you just need to solve the problem for a modulo x plus y. Now if this remainder is, if this is 1, that means in the next step, if the first person digs it, he would dig 1 meter. So then after the first person digs it, if it doesn't exceed this a, then it means the second person is going to find the treasure, and if it exceeds a, then first person is going to find the treasure. So basically this value, which is a modulo x plus y, if this exceeds s x, then you would say that the second person finds it. That means you will return a yes, else you will return a no. Okay, I hope the explanation is quite clear to you, and this was a very easy problem. So I hope there won't be too much difficulty in the code as well. You have to just write this if condition. That's all. Okay, so I'll show you the code. So I modified my a as a modulo x plus y, and then I just checked whether it is less than x. Okay, so if that is less than x, then I'll say a no. Okay, else I'll say a yes. Okay, so even if it is equal to x, okay, so I have to write even if it is equal to x, then the second person is going to win, so it would be a yes. So I've just written opposite here. For less than x, I have written no, else yes. Okay, here what I've written, for greater than or equal to yes, else no. Both are the same thing. So I hope this is clear to you. Its space and time complexity both are constant. So O of 1 time and O of 1 space. Okay, so I think we can move on to the next problem now, if there is no doubts regarding this problem. Okay, so let's move on to problem B, which is pushing balls. So Arcade has n cross m grid, originally empty, and he has pushed several balls in it. Each time he can push one ball into the grid either from the leftmost edge of a particular row or the topmost edge of a particular column of the grid. Okay, so when a ball moves towards a position, if there is no ball originally at that position, the incoming ball will stop and occupy the position. And if there is already a ball, then incoming ball would stop and occupy the position, as well as the original ball would continue moving to the next position in the same direction. So what does this mean? I'll explain you, but what you need to find the final state of whether there is a ball at each position. You need to determine whether it is possible. So you are just given a final state where 1 represents that there is a ball, 0 represents there is not a ball, and you just need to determine whether it is possible to create this create this final state. So I'll explain you the problem statement first, what it is trying to say. So basically you have a grid. Uh, so basically you have a grid of n cross m, and then you just need to what is happening here, I don't know why this shift is not working today. Okay, no issues. So you can assume we have a grid. Now, what the problem says is, in this grid of n cross m, you initially all the grids are empty. Okay, all the places are empty. So what happens is, what you can do is, you can start with any of the cells in the leftmost column or any of the cells in the topmost row. Okay, so you can start from either from these positions or from these positions. Okay, let's say what you can do, if you start from the leftmost position, then you can push a ball in this direction. Okay, so you can just take a ball and push it in this direction. Or what you can do, you can start from the top and push it in the downward direction. These are the two types of moves that you can perform basically. So what you can create through these moves, so what happens, let's say you started with this step, you pushed a ball from this side. So initially there was nothing here, so if it is an empty space, it would just occupy that space and remain there. Okay, so now next time, let's say again you pushed another ball in this direction. So now this second ball, when it would come to this cell, it sees that there is already a ball. So what it would do is, it would occupy the place of this ball. Okay, let's say this is a red ball. Now it occupies the space of this previous ball, and that previous ball moves forward, continues to move forward. Okay, so here it was an empty space, so it occupies this space. So this is the position after. Okay, initially in the first step, a blue ball was thrown here, then a red ball was thrown. Okay, so these two spaces would be occupied. Let's say again you threw one more ball from this direction. So if you threw one more ball from this direction, then it would see here the place is already occupied. So he would instead replace it. It would just replace this ball and occupy its position and push that red ball forward. So now that ball would go forward here and replace this blue ball. Okay, so it would replace this blue ball, and this blue ball would move forward and it would just occupy this position. So what happened after pushing three balls? These three consecutive rows got occupied. Same way you can do the same thing from the top. Maybe you can push a ball here, and then again if you push another ball, this would be pushed down, and basically it would create like this. Again, if you push another ball, then all these three balls would be pushed down, and the new ball would occupy this position, and all the three balls would be pushed down. So basically with each step, what you can do is, either from the left side you are pushing the ball, effectively you are pushing a ball into the first non-empty space available. So in this row, the first non-empty space available, the ball would go there. Effectively you can assume that, because the ball goes here and it pushes the all these ball relatively one step ahead. So you can assume that the new ball is placed here, because the balls are not differentiating. So basically the move is, you can start from the leftmost column and push a ball in the first unoccupied place in that column. Okay, or you can start from the topmost column and push the ball in the first unoccupied space in that row. Okay, so these are the two actions that you can perform. So after performing these actions, you need to determine whether we can create the final appearance like given in the test case. Okay, so you are given a string of 0 1, a binary string of 0 1, which represents that you have a grid like this. If it is n is 3 and m is 3, so you have a 3 cross 3 grid, and it is like this. 0 represents that there is no ball here, it's empty, and 1 represents that there is some ball here. Okay, so these are empty, and there is some ball here, there is some ball here, and this is empty. So this is the, you need to determine whether you can reach this state. Okay, so if you look at this particular state, what you can do, you can push a ball from here, it would come here, then you can push another ball from here, you would have two balls here. then you can push one ball here, then another ball here, you would have two balls here. So this way you can create this state. So you would answer a yes, that yes, you can, this state can be created through some way. If you look at, let's say, this last test case, then here it is like this. You have a ball here and rest all the spaces are empty. So is it possible to create this state? If you push a ball from the left, it would see this space is empty and occupy this space. In order to push a ball till here, you have to have balls here and here as well. Then only you can push a ball till here. Or from the top side, if you want to push, then you need to have the balls here or here in order to push a ball till here. But for this ball, neither you can push it from the left side nor from the top side, because there are empty locations before it, so if you push a ball, it would occupy the empty location first before moving forward. So what you need to check now is, wherever you have a ball, a ball can come at a place only if either it is pushed from the top or pushed from the left. So either from the top, before it there is no zero, there is no empty space before it. Okay, so for any particular position, if you want to check whether it is possible to have a ball there or not in your final state, what you can do is, if you want to check a position, just check either all the positions to the top of it should have 1 1 1, or all the positions to the left of it should have 1 1 1. Basically, either all the positions to above it should be occupied, or all the positions to the left of it should be occupied. If either of these cases happens, then it's okay, this ball can come here. So your answer would be no, only if there is some position ij such that there is a 0 to the left of it as well as a 0 to the top of it. Okay, so then you would answer a no. So when would you answer a no? If you find such an ij, so that for it, if you check all the positions to the left of it, you would find a 0, and if you check all the positions above it, you find a 0. If you find a 0 above it as well as to the left of it, that means it is not possible to have a ball here. That means your answer is no. This state is, you are not able to create this state. Otherwise, if none of such cases happen, then you answer a yes. So what would be the complexity to check it? Just if you are checking for all the grids, okay, so there are n cross m positions in the grid, and for checking any positions, you go all the positions to the top and all the positions to the left. So going all the positions to the top would be O of n, and going all positions to the left would be O of m. Okay, so basically the checking thing would be done in order of n plus m. Okay, and for each cell you are checking for n into m cells. So basically your overall complexity for the brute force approach would be n into m into n plus m. Okay, so in this complexity, in the brute approach, you can do it. And if you look at the constraints, it was just 50-50. So this would be really less, like 50 into 50 into 100. Okay, so this is 25, 1 2 3 4. So this would be well accepted, there is no issues with it. Okay, for sum of n into n is also for each test case, so this into 2 is not multiplied. So this is just the overall time complexity, so even a brute force would work in this problem. So you just need to do that, implement that thing. I hope it is clear. Let's look at the code. So we just took the input, and then I'm checking for every cell. I'm going for all I from 0 to n, all j from 0 to m. So I'm going to every combination of ij. And first, if that a of ij is 0, if there is no ball in that, then no need to check it. We only need to check for those cells where there is a ball. We need to check whether a ball can come there or not. Okay, so if there is a ball at the cell ij, then I would first check all the cells to the left of it. So if this cell is I comma j, what would be the cells to the left of it? it would be some k comma j such that k is less than I. So just go to all the k less than I and check for k comma j. So I'm going to all the k from 0 to less than I, and I'm checking if a of k comma j is 0. So if you find even a single 0 in this boolean variable f, I would store that yes, you found a 0, f equal to 0, and break. Okay, so even if you found a single 0, then you made it f equal to 0 and break. If you didn't find a single 0, that means in the left all of the spaces are occupied. That means you can push a ball there from the left. So you'll say a continue, that yes, it is fine. If there is no 0 present to the left, then it is fine. Okay, and if there is a 0 present to the left, your f would become 0, so you would move forward. You would start checking whether we can push from the top, because it is not possible to push from the left. So for the top, again, if you have to check for ij, all the cells to the top would be I comma k such that k is less than j. Okay, so all I comma k says that k is less than j. So for all k from 0 to j, I check from I comma k. If you get a 0, again you'll change your boolean variable to f to 0. So if you found a 0 in this case as well, then your answer would become no and you would return out. If you don't find a 0 this time, then it's fine. Check for the next case. Okay, so even if there is one ij for which it is not satisfied, you will answer no and return out. This return would just return out of the whole test case. Okay, so if there is no, then that your answer is yes. Okay, I hope it is clear. If you analyze the time complexity, then this is an order of n loop for taking the input. This is n into m. Inside, this is running at max n times. This is running at max m times. So in total, inside you are running n plus m times, and this is n cross m. So this is overall n into m into n plus m. Okay, so that would be your time complexity. And your space complexity would be, you're just using this string vector of string of size n cross m. It would have n cross m characters, so that would be your space complexity. Okay, so I hope this problem is clear to you. We can move on to the next problem now. Okay, is there any more doubts in this problem? Okay, so I think we can move to the problem C. So in problem C, what do we have is, inside the large kingdom, there is an infinite dining hall. It can be represented as set of cells xy, where xy are natural numbers. There's also infinite number of tables. Okay, I'll explain you what the problem statement states. Okay, instead of reading this whole story. So basically, you have an arrangement like this, where you have some. Okay, so in this infinite grid, you have tables like this. So you will have this one row left, that would be a corridor, and then you would have a 2 cross 2 table. So there would be 4 seats in that table. Then again, these rows would be left as a corridor, and then a 2 cross 2 table. Then this is a corridor. Okay, then a 2 cross 2 table. So these gray areas are the tables. Each table has 4 seats. Okay, and the remaining cells are just corridors, free walking spaces. Okay, now what happens, you start with, okay, so there are n people, and all the people are of two types, either type 0 or type 1. Okay, so one by one every person would come. So what would what would type 1 person would do? He would be initially at 0 comma 0. Then he would check which is the closest seat which is unoccupied. Okay, so here what the first person would do, first person is type 0, let's say. Okay, in this it is type 0. So what we have said is, for type 0, For type 1, they sit at the nearest table that still has space available, and for type 0, they sit at nearest table that is unoccupied, although others may join them in future. Okay, so the type 1 person just finds the nearest seat which is available to him and goes and sits there. But the type 0 person, he would find the nearest table which is completely unoccupied, and he would sit in a seat in that table. So if there is some seats in a table which are occupied, then he would just reject that table completely, and he would just look for tables which are completely unoccupied. So among the tables which are completely unoccupied, he would look at the closest seat where he can sit, and he would sit there. So that is for type 0. And for type 1, he would just find the closest seat which is unoccupied and sit there. So that way, every person would one by one go and sit, and you just need to find the position where every person would sit. Okay. So one by one, if they are sitting, you just need to find where every person is going to sit. So you can look at the first test case, what is happening. The first person is 0, then 1, 1, 0, 0, 1. Okay. So this is the first test case. Okay. So the first person would come, he is a type 0 person. So he would try to find a seat which is completely a table which is completely unoccupied. So initially all the tables are completely unoccupied. So from this, which is the closest seat available to him, is this. Okay, so he went and sat at this seat. Now the second person, he is a type 1 person. So type 1 person would just find the closest unoccupied seat. So the closest unoccupied seat from here, this seat was unoccupied, so it is 1, 2 and 3 steps. This seat is also occupied, it is 1, 2 and 3 steps. So if there is a tie in the distance, then it is said that you prefer first the x coordinate, whichever has a lower x coordinate, he would sit there. And if x coordinate is also same, then the tie would be broken using y coordinate. So among both these positions, its x coordinate is 1 and its x coordinate is 2. So this has a lower x coordinate, so he would prefer this position. So second person goes and sits here. Now for the third person, he is also a type 1 person, so he would again find the closest seat. So closest available seat was this here this time, so he went and sat there. For the fourth person, he is a type 0 person, so he would find the closest table which is completely unoccupied. So this table was occupied by few people, so he would ignore this seat. Although this seat is unoccupied, but he would not try to sit there because this table is occupied. He's a type 0 person. So then he saw that this table is completely unoccupied, this table is completely unoccupied. So he can go and sit here. It would cost him 1, 2, 3, 4 and 5 steps. Or he can go and sit here 1, 2, 3, 4 and 5 steps. So both of them are 5 steps. This has lower x coordinate. So the fourth person went and sat there. Okay, so 1, 2, 3, the fourth person went and sat there. Now what about the fifth person? He is also a type 0 person. So although he can go and sit at this or this position, but these positions are from tables which are already occupied, so he would ignore them. He would see that this table is still unoccupied, so he would go and sit at this position which was the closest, so he went and sat there. Now for the last person, he's a type 1 person, so he would just go and sit at some position which is unoccupied. So he would just see which position is unoccupied. So this position was unoccupied, this position was unoccupied, these were unoccupied. So for this position, it would take him 1, 2, 3, 4, 5 and 6 steps. Okay, so you cannot cross a table and move to your position. You have to walk in the corridors, and at the end you have to just come to your position where you have to sit. So for this position, it's not 1, 2 then 3, 4. You cannot move like this. Okay, you have to move from above and move here. So it would cost him 1, 2, 3, 4, 5, 6 for this position. What about this position? 1, 2, 3, 4, 5, 6. This also cost 6 distance. So both of them, the distance is 6. So this has lower x coordinates. So he went and sat there. Okay. So I hope this test case is clear, and what you need to do, that is clear. Now, how do you solve this problem? You can look, the constraints are n is 50,000. So it's 5e4. You cannot run something of order of n square. If you run something of n square, it would go 25e8. So that would give you TLE. So you have to do in something order of n or n log n, something like that. Okay, that you have to keep in mind. Now, how do you do this? Okay, so what you need to notice here is, first of all, like initially when you are initially for the first person, what are the available options for him? Okay, this is an infinite. Like if you look, if you just try to think the brute approach, that what we can do. So this is an infinite coordinate system, and infinite number of tables are available here. So among all the positions, which is the closest position for this person which is unoccupied? So one way to solve this problem is just maybe in some priority queue push all the positions along with their distance from this initial 0 comma 0. Okay, so we will look how we can calculate the distance exactly, but for now, let's say you know from 0 comma 0 what is the distance of this position, what is the distance of this position. So what can be one approach? Okay, you cannot cross and go like this, you have to go like this. Okay, so what is one way to solve this problem? If you can somehow find calculate this distance, okay, we'll look how we can calculate what would be the formula, or how can we calculate this distance. But let's assume that you somehow found this the shortest distance to all the positions. Then what you can do, you can just push all the positions in a priority queue according to their distance. So the priority queue would be the priority of the priority queue would be the distance from the 0 comma 0. So once all the positions are in your priority queue, so whenever you get a type 1 person, what does a type 1 person do? He just picks an unoccupied position among all the positions which is at the shortest distance. So among all the positions from the priority queue, you can just take out the positions with the minimum distance and assign to that person and remove it from the priority queue. Okay, for what would you do for a type 0 person? Now for type 0 person, if let's say you for type 0 person, if let's say this position was already occupied, then for type 1 person these positions were open for him, but for type 0 person these positions are not open. So for type 0 you can just maintain another priority queue, a different priority queue from that, and in that you can store the tables that are unoccupied. So you can just push all the tables in it. So this group, okay, these group of 4 positions, let's name it table number 1. So push table number 1, table number 2, table number 3. So whenever a person occupies a position from table number 1, just remove that table number 1 from the second priority queue as well. Priority queue of 0, remove it from this as well. That way, among the tables, you just need to find from the second priority queue which has the tables in it, which table is at the shortest distance. Okay, so this way, using maintaining 2 priority queues, one for type 1 person which would store all the positions along with the distance, and the second priority queue would be for the type 2 person which would store all the unoccupied tables. Okay, and then you whenever you give a position to any of the person, you need to update both of the priority queue. Okay, remove the table which to which it belongs from the second priority queue, and remove the cell to which it belongs from the first priority queue. Okay, so that way you can solve this problem. This one approach like comes to your mind, but one small difficulty in this also would be there are infinite number of coordinates and infinite number of tables available here. So how do you like how do you push what all tables would you push in your priority queue? You cannot push all the infinite tables into your priority queue. Now also you can see your n is 50,000. So one way to do it is all the n cross n. Okay, so you would never go out of these n square tables. Okay, the first n tables from here and n tables from here. If you take these n square tables, you would never take occupy a position from a table out of these n square tables. First, you would try to fill these tables. So one thing is you can push all these n square tables into a priority queue. But again, this n square would exceed our time limit and space limit both. So you need to just use a little bit of more optimization to solve this problem. What you can do is, okay, so here you have an infinite grid with some tables in it. So what you can do is, initially for the first person, when all the tables are unoccupied, which are the available options from which he would choose? Although there are infinite options available to him, but first person would always occupy this position. Like, this is for sure from the first table. Now let's move to the second person. Let's say the first person already occupies this position. For the second person, if let's say he's a type 0 person, this table is already unoccupied. Which are the available options for the second person? You may say you have this, all of them. But actually, if you only push into your priority queue initially, if you only push this, and then when you have this occupied, then you can push this one and this one, these both. So for the second person, if this is occupied, then these two would be the most closest options available to him, or maybe this, if this is coming shorter than turning something like this. So at max, whenever you occupy a position in this table, you can push all the adjacent tables into a priority queue. Now when you occupy this position, push all the adjacent tables into a priority queue. So don't fill your priority queue initially with all the n square tables. Rather, fill it initially with, let's say, just this table. Then once you occupy a position in this table, put all the adjacent tables. Once you occupy a position in this table, put all the adjacent positions. So if there are n people, then in n steps, at max you would push, let's say, 3-4 tables in every step. So it would be in order of n log n only, the your time complexity. For pushing into a priority queue, that would take log n time, and at max you are pushing 3n times, 4n times, 5n times, that much only. So that would remain in order of n log n only, your push operation. And same for n positions, you would erase n times. So in overall n log n time only, you can solve this problem if you don't push all the positions into your priority queue initially, but one by one push only those positions which are a candidate to be the minimum. Okay, so initially only this table is a candidate to be the minimum. Then all these adjacent become a candidate. Then after this, these adjacent become a candidate. Now, also, how far adjacent do you need to take? For this table, if you take only these three, then there is also a point that, okay, so that would be determined with the distance. First, let's try to find out the distance. Okay, so then we would analyze how we can do. So one problem still remains with us is, how do we find the distance of any particular position from the start? Okay, so if you look closely, for any particular position, okay, so for any table you have 4 positions. Okay. Okay, so for any position you have, for any table you have 4 positions. What would be the distance for these 3 positions? Like, here you can see what are the coordinates of those 4 positions. The coordinates of the positions are defined by 3x plus 1, 3y plus 1. This is the first. Okay, so these 4 positions define your coordinates. How that is working, I'll just show you. Okay, so here like you can see how the coordinates are. This is 0 comma 0, 0 comma 1, 0 comma 2, like 0 comma 0, 1 comma 0, 2 comma 0, and here you have 0 comma 1, 0 comma 2. Now it is saying the four coordinates are of any particular table 3x plus 1, 3y plus 1. So if you take x equal to 0, y equal to 0, what you get? 3x plus 1, 3y plus 1, that would be 1 comma 1. So this position is actually 1 comma 1. If you take 3x plus 1 and 3y plus 2, so it's 1 comma 2. So this position is actually 1 comma 2. Then if you take 3x plus 2 and 3y plus 1, it is actually 2 comma 1. So this position is your 2 comma 1. Okay, and then the last one is 3x plus 2, 3y plus 2. So this position would be 2 comma 2. So for x equal to 0, y equal to 0, you get these four positions of table number 1. Let's say you change your x to 1, x to 0, and y to 1. Okay, then what you would get? The first one would be 3x plus 2, 3x plus 1, and 3y plus 1. Okay, these are where the four positions. So if you look at these four positions for x equal to 0, y equal to 1, you get 1 comma 3 plus 1, 4. So from this you get 1 comma 4. From this you get 2 comma 4. From this you get 1 comma 5, and from this you get 2 comma 5. Okay, so these positions are 1 comma 4 is this position. This is your 1 comma 4. 2 comma 4 is this position. This is 2 comma 4. And then 1 comma 5 is this position. This is 1 comma 5, and 2 comma 5 is this position. This is 2 comma 5. Okay, so you can see for every different pair of x comma y. So for x equal to 0, y equal to 0, you got the four coordinates of this table. For x equal to 0, y equal to 1, you got the four coordinates of this table. Same way for this table, you would have x equal to 1 and y equal to 0. With this, you would get the four coordinates of this table. Okay, I hope this mathematical form is clear to you. Now, how do you get the minimum distance? So let's say for any table from 0 comma 0, what would be the minimum distance to this? If this is x comma y, so you move x forward and y to the right, you reach here, or y to the right and x above, you reach here. So for this position, whatever is its coordinate, okay, here let's say I'm telling this as capital X and capital Y. Okay, this x and y is different. Okay, so here what I was mentioning is capital X and capital Y. Okay, now this exact coordinate 1 comma 4, 2 comma 4, 1 comma 5, this x and y is what I'm referring as small x and small y. Now if this exact coordinate is small x and small y, your distance from here to here would be x plus y. Move like this. For this it would be move x here, y here. For this also, whatever, if this is x dash and y dash, it would be x dash plus y dash. For this also, if it is x double dash and y double dash, move y above and x to the right, you get x dash double dash plus y double dash. But for for these three positions, always you can move like this, like this, like this. So you would always have your Manhattan distance only, which is x plus y. But for this position, if you want to have x plus y, you would have to move like this or like this, crossing something. But you cannot do like this, so you would have to move from here to here. Okay, so if you are moving like this, that means if you were to move like this, from that you are moving one extra above and one extra below. Basically it is x plus y plus 2. You are moving two steps extra, one above and one below. So instead of following your shortest path of x plus y, you are following this x plus 1 above and then one more down. So y plus 2 would be your vertical distance, and horizontal you are moving x only. So actually for this, if it is x triple dash and y triple dash, then your distance for this would be x triple dash plus y triple dash plus 2. Okay, so for all of these three positions, your distance is the sum of the coordinates, but for this, your distance is a plus 2. Same thing you can analyze for any table in the middle as well. For this position, you can move through this corridor, and then you can move like this. Okay, so this step would take you x plus y only. In vertical, you are moving a total of y, in horizontal a total of x. So you are not moving down or left, that's why you are only moving above and right. So that's why you only get x plus y. If you were to move down somewhere, then you get extra. So for this position, you can do in x plus y. For this position as well, you can move like this in x plus y. For this position also, you can move like this in x plus y. So for all these three positions, you can always move directly in x plus y. But for this position, again, you cannot move directly, because in order to come directly, you have to either move from here or here, and these positions are blocked. So you have to move like this. Again, 2 extra here. So always for all these three positions in your table, what would be your distances? So the three positions in your table are 3x 3x plus 1, 3y plus 1 is your this position. 3x plus 2, 3y plus 1 is this position. 3x plus 1, 3y plus 2 is this position, and this fourth position is 3x plus 2 and 3y plus 2. What are your shortest distances from these positions? For these three, it would be just sum of coordinates. So for it, it would be 3x plus 3y plus 2. For this, it would be 3x plus 3y plus 3. 3x plus 3y plus 3. For this, it would be sum of coordinates plus 2 extra. Okay, so 3x plus 3y plus 4 and plus 2, it becomes plus 6. So for any table, these are the 4 coordinates of the table, and these are the 4 distances of that table. Okay, so I hope it is clear to you how we can find the distance. Now, once this part is done, then what's left to find out? So only for when you are using this table, then which all neighboring tables do you need to push into your priority queue? So basically, if this was your minimum, then the next minimum can be among this table, this table, this table. Okay, so this distance thing is clear. Now in our algorithm, what I'm doing is I'm pushing initially this table and all these 4 positions into my priority queue. Then once I take any element from this table, then I'll push all the neighboring tables into my priority queue, as well as I am pushing 2 neighboring tables in order to be extra safe. Okay, so what I'm doing, so if I'm taking something out from this table, I'm pushing this, and this, all these 5 tables. Because why I'm pushing 2 neighboring tables? Because for if I'm telling about this position, okay, so if I'm pushing this table, then this position is some 2 extra, and this may be shorter than that. Okay, so if I'm pushing this, I'm also pushing this, so that I'm extra safe. Because for these 2 positions, just compare these 2 positions, this position and this position. Okay, so if I'm pushing this table, knowing that my next shortest distance is going to be among this from this table only, but this distance is actually shorter than this, because here I have a plus 6, here I have a plus 2 only, and then this x and y coordinate is plus 2 extra. So these 2 distances are actually same, as you can you would have seen from this test case also, that this distance and this distance were same. Okay, and this was even shorter, and this had lesser x coordinate. So obviously if you are pushing this, for some of the positions this may be farther than positions in this table. That's why I'm pushing two adjacent tables into my priority queue if I'm removing something from this table. So two adjacent positions from the top, two adjacent to the right, and one adjacent diagonally. Once I have pushed all these five tables, then I'm for sure that my next shortest distance would be among them only. It won't be anything apart from them. Okay, actually just pushing these three were also enough, because this was creating the shortest distance, but just for extra safety I'm pushing all the five. Okay, so I hope this thing is clear. So I think already I had explained you the algorithm. What I would do, I would maintain two priority queues. Let's explain you that from the code again. Okay, so you can see the code. I'm maintaining two priority queues. One PQ0 for type 0 person, which would store the tables. Okay, and second one is PQ1 for type 1 person, which would store all the positions. Okay, now initially what I'm doing is I'm using a set here basically instead of a priority queue, because in a priority queue I cannot erase an element what I wish to erase. I can only erase from the top. So in a set I can erase any element which I wish. So whenever I push from the top of this priority queue, I use something from the top of this priority queue, I need to erase that from this priority queue as well, which may be in the middle somewhere. So that's why I'm using a set instead of a priority queue. So it would work the same in log n complexity only. So these are two sets you can assume, which are working as a priority queue only in our use case. And then another set which is just storing which all tables are already pushed, because it may happen that I use a position here, then I push these five tables, then if I use another position here again I would be pushing these five tables. So I don't want to push the same table multiple times into my priority queue. So I'll just, in a set I'll just maintain the positions which are already pushed. I'll check if this position is not pushed already, then only I'll push. Okay, so that's what I'm just marking, whether this is already pushed or not in this set. Okay, so this I've just created the push function whenever I have to push a table into my priority queue. What I do, so if I have to push table number x comma y, here it is capital X comma capital Y. Okay, that means I have to push these four positions into my priority queue. So in my PQ0 I only have to push the table, so I push x comma y, and here I take the distance. The closest distance was 3x plus 3y plus 2. So this distance and x comma y. So I have pushed the table number x comma y in my priority queue 0. In my priority queue 1, I have to push all these four positions. Okay. So for type 1 person, I'm using priority queue 1. In this, I have to push all the four positions. So all these four positions I have pushed along with their distances. So here this is the distance, this is x coordinate, and this is y coordinate. Okay, so for all the four of them I pushed these distance, x coordinate, y coordinate, like that. I pushed all the four, and in my set I have inserted this xy, marking it that it is already pushed. So before pushing I just check if I don't find this in the set. If I already find this in the set, it's not equal to st.n, then I return out. I don't push anything. Okay, this is already pushed. But if I don't find it in the set, then only I'm pushing and adding it to the set. Okay, so this, I've created my push function. Whenever I pick any coordinate, I push all its adjacent tables into my priority queues. Okay, so initially I'll push these initial three tables. Initially I'll push this and this, these three initial tables, 0 0 0 1 and 1 0. Okay, now I'll start with my iterations. I'll pick the from the first person to the nth person one by one. If it is a type 0 person, then I'll pick from the priority queue 0. Okay, so this v stores the distance in v0 I have distance, likewise how I have pushed. In v0 I have distance, in v1 I have x coordinate, in v2 I have y coordinate. So I got the capital X and capital Y through v1 and v2. So now this is the table. So this type 0 person needed a new table. So from this table my answer would be, so if I'm entering a new table, I would always pick this position because this has the closest distance. So I have picked this position as my answer for this one. So this position would be 3x plus 1. So I've just printed my answer, 3x plus 1, 3y plus 1. This was my answer for this particular person. And I have erased this position from both of my priority queues. So from priority queue, I can directly erase this v because I've extracted that from my 0 priority queue only. But for priority queue 1, I need to just remove this particular position, not all the 4 positions. Okay, so this particular position is 3x plus 1, 3y plus 1, and the distance is 3x plus 3y plus 2. Okay, so this particular position got erased from my priority queue 1, and this table got erased from priority queue 0. Okay, so both erase thing is done, printing the answer is done. Then I just need to push all the adjacent, these 5 tables, these 5 adjacent tables I need to push into my priority queue. So x plus 1y, x plus 2y, xy plus 1, xy plus 2, these 4, and this diagonal one. So all the 5 tables I have pushed into my priority queue after getting this position. Same way for type 1 person, I'll pick up from priority queue 1. Okay, I'll pick up the closest unoccupied position. And in type 1, in priority queue 1, I've stored 3x plus 1 and 3y plus 1. How do you get x from that? From this, if you divide it by 3, then whether it is 3x plus 1 or 3x plus 2, integer division by 3 would give you me my x, and same way for y. So my x is v1 by 3 and y is v2 by 3. So I got my capital X and capital Y. Then I just erase that table from my priority queue 0, the xy table having distance 3x plus 3y plus 2. This table got erased from priority queue 0, and from priority queue 1, this whole vector got erased. Okay, so erase thing is done. And what is my answer? My answer is whatever the x and y coordinates were there. v1 and v2 were my x and y coordinates of my current extracted. And then same way I push these 5 adjacent positions into my priority. So once this is done, I have printed my answers for all the n people. My code is done. Okay, so I hope this is clear to you. If you have any doubts, please write down in the chat. Okay, is there any doubts in this problem, or is it completely clear to you? So if you analyze the time complexity, this input part is taking order of n time, and then this is a function. Now this for loop is running n times. Inside that, this erase is taking log n time. This push is at max taking 4 times log n, 4 times or 5 times insert function. So at max 4 into 5, maybe 20 times I am running the insert function. But overall, this would push only x into y times only. So overall, this would be some constant into log n. So 10 log n or 15 or 20 log n, whatever that is overall. Okay, here also. So overall, it's n into log n only. Okay, and with a heavier constant. Okay, so it's n into log n with some heavier constant. So overall, my time complexity would be order of n log n. And what would be my space complexity? I'm just using a priority queue which would at max take 4 and 5 and that many coordinates only. So this would be order of n size, this set would also be order of n size, and this vector is also order of n size. So my space complexity is also order of n. The constant may be a little heavier, but the order is n only. Okay, so I think this problem is completely clear to you all. We can move to the next problem now. Okay, so the next problem is simple permutation. So given an integer n, construct a permutation of length n that satisfies the following property. So for I from 1 to n, we define Ci as the sum from P1 to Pi divided by I. Basically, Ci is the average of the first I elements. Then among C1 to Cn, there must be at least n by 3 minus 1 prime numbers. That's what we need to make sure. So what you need to find out is you are given a n. So you are given a n. You need to form a permutation of size n such that if you take the average, you need to form a permutation of size n where C is the Ci would be the average of the first I elements. Okay. Sum of the first I elements divided by I. Integer divided by I. So this one would be just P1 divided by 1. This would be P1 plus P2 divided by 2. This would be P1 plus P2 plus P3 divided by 3. Likewise. So whatever values you get in this array, what you need to make sure is out of the n values in this array, at least n by 3, the floor division of n by 3 minus 1, at least there should be this much prime numbers. Okay. So you need to find such a permutation of size n that when you take this second array, which is calculating the average till the ith element, then in this array you should have at least n by 3 minus 1 elements which are prime numbers. Okay, at least this many prime numbers you should have. So you need to form such an permutation. Okay, so how do you do this? Just let's look at a few test cases. N equal to 2, 3, 5 cases. Let's say for n equal to 2. Now n equal to 2, how, with n equal to 2, what is the required number of prime numbers? It's n by 3 minus 1. So it's 2 by 3 minus 1 is 0 minus 1 minus 1. So basically for n equal to 2, even if you don't have any prime numbers, there is no worry. Required number of prime numbers is minus 1. So for n equal to 2, you can just print any permutation. It doesn't matter. Even for n equal to 3, what is the required number? It's n by 3 minus 1, which is 3 by 3 minus 1, 0. So here also the required number of prime numbers is 0. So for n equal to 4 also it would be 0, 5 also it would be 0. For n equal to 6 is from where your question actually starts. Here your required number of prime numbers would be n by 3 minus 1, 6 by 3 minus 1 would be 1. So here you would require at least one prime number among the first n averages. For maybe n equal to 14, something like that, your required prime numbers would be 14 by 3 minus 1. It is 4 minus 1, 3. So for n equal to 14, you should have at least 3 prime numbers in your average array. So this was some required analysis. Like here in the sample input, you didn't get any much information about this problem because for 2, 3, 5, for all of them, there was no required number of prime numbers. Still, in this problem, in the given output, there are some prime numbers that are formed. So for 2, if you are outputting a permutation of 2 comma 1, okay, then what is the average that you get? Here it would be 2 divided by 1, 2. Here it would be 2 plus 1 by 2. So 2 plus 1 by 2 is 3 by 2. It would be 1. Uh, you have to take, I think, the C layer, right? You have to take the C layer, okay, not the floor. So here it would be seal of 2 plus 1 by 2. So that would be 2. So 2 is prime, 2 is also prime. So here you got both of the numbers prime only. So actually the required was minus 1, but still you got 2 prime numbers. That is also completely fine. Let's say for, let's say one more test case. For n equal to 5, this is what the permutation is given to you. Let's see how many prime numbers do we have in this. Again, for n equal to 5, the required was 0 only, but still you can make some prime numbers. So for 2 it was 2. 2 plus 1 by 2 is 3 by 2. The seal of 3 by 2 is 2. Then 2 plus 1 plus 3 is 6 by 2 is 6 by 3 is 2. Then 6 plus 4 10. 10 by 4. 10 by 4, the seal of 10 by 4 would be 3. And then 15 by 5 would be 3. So here you can see all of the numbers are prime actually. All the 5 numbers are prime. So for these small numbers, you are able to generate a lot of prime numbers. Okay, so let's just try to find some construction through which we can ensure this for n up till 1e5 as well. Okay, so even for some n up till 10 to the power 5, we can have. So let's say for small arrays, it was really easy, like making this. Okay, but we'll discuss how we can make this, but we eventually need to solve the problem for big n. So let's try to imagine the problem for some big n. So if n is somewhat like 1e5, then we need to make sure we have n by 3 minus 1 prime numbers at least. So like 10 to the power 5 by 3, it's more than 10 to the power 4 prime numbers. So we need to have a lot of prime numbers in this. So for initial construction, as from the sample test case, you will think, yeah, we can maybe initially try to make all the averages 2 2 2, then 3 3 3. Okay, so for initial few values you would get some 2s and some 3s, but after that it would become difficult because your values would start increasing. You need to have all the values from 1 up till n. So for smaller values you would get the average initially as 2 or 3, but after that once the values start increasing, maybe you can get 5 and 7 sometime. But for really large values, this method may not work. But how can you make sure that your method is working is what you can do. You need to have at least n by 3. Okay, so one possible construction for this is, let's say, how can you just maintain your average to some constant value? If let's say you suppose that there is a prime number p, and you want that all your averages should be p, or not all, at least n by 3 averages should all be equal to p, then how do you try to maintain your average to some constant value p? What you can do, if you want to maintain your average p, maybe you can, let's say you want p is 5. What you can do, you can first add 1 and then you can add a 9. So 1 plus 9, 10 by 2 would be 5. Then you can add 2 and 8. 2 and 8 would sum up to 10. So these two values would maintain an average of 5. So after these two values, again you would maintain an average of 5. So the sum of all these four values would remain with an average of 5. Then you can add 3 7, then you can add 4 6, then you can add a 5. So this way, if you want to maintain an average of 5, you can start with 1 and what is required. 9 is required to maintain an average of 5. So after these two numbers, your average would be 5. Then add 2 and 8. Again, your average becomes 5. Then add 3 and 7. Again, your average becomes 5. Then add 4 and 6. Again, your average becomes 5. Then add a 5. Again, your average remains 5. So here you were able to add 9 numbers. Out of them, after 5 of the numbers, your average was 5. So at least if you are adding here, if you're adding x numbers, then at least x by 2 numbers are having an average of 5. But at max you can create 5 numbers like that. After 5 you cannot now go on with 6,4 because you have already used 4 and 6. So you need to find out some bigger number. Let's say for this n, if let's suppose my n by 2 was a prime number, if let's suppose my n by 2 was a prime number, so I can add not n by 2, let's say my n plus 1 by 2. So what I can do, I can use 1 and end, this average would be n plus 1 by 2. Then I can use 2 comma n minus 1, this again would average out to n plus 1 by 2. Then I can use 3 comma n minus 2, 4 comma n minus 3. Likewise, I can go on up till n by 2, n plus 1 by 2, like that. It would depend in odd or even whether you would have one number here or two number here. So if I'm doing like this, then for out of these n numbers, for half of the numbers, for n by 2 numbers, I'm maintaining an average of n plus 1 by 2. And if this number was a prime number, then I needed to have only n by 3 minus 1 prime numbers, but I already have n by 2 prime numbers. But okay, you would not always find n plus 1 by 2 as a prime number. Then maybe you can go a little lower. Okay, so if your, let's say, n was 20, what you needed to have is, let's say, n was 21. So n plus 1 by 2 is 22 by 2, 11. Or let's say we have 23. Okay, so n plus 1 by 2 would be 23 plus 1 by 2, it would be 12. So here you can see 12 is not a prime number. So if you try to make this construction 123, 222, 321, these all would average up to 12. But this is not a prime number, so there's no benefit of doing this construction. But you can just go down from 12. Maybe let's take 11. Let's try to make 11. 11 is a prime number. So with 1, to make an average of 11, you would require a sum of 22. So 21. So 1 and 21 would make a sum of 22 by 2, 11. So 121, 220, 319, okay, 418, 517. This way you can continue up to 11. This way you can continue up to 10, 12, and then an 11. So this way, out of the, and for n equal to 23, since n plus 1 by 2, this 12 was not a prime number, but you went down from 12 and found the first prime number, which was 11, just below 12. So you made a construction to constitute this 11. So after these numbers, you have 11 prime numbers. After these two, you got a prime average. Then after these two, you got a prime average. Again, you got a prime average. So here you have already added these 10 into 2, 20 numbers and 121 numbers. Out of these 23 numbers, 21 numbers are already added, and you have 11 prime numbers out of them. And after that, you can just add the remaining numbers in your permutation. It doesn't matter. So you can add 22 and 23, which were not already added in this permutation. So you started with 121 and added all the numbers from 1 to 10 and 11 to 21. So 22, 23 were remaining. You add that at the end, no problem. But you got 11 prime numbers here. You only needed 23 by 3 minus 1, which was like 7 minus 1, 6. You only needed 6 prime numbers, but you got 11 here. You got enough. So if you can find, if there is no problem if n plus 1 by 2 is not a prime number, if you can find a prime number below n plus 1 by 2, but it is at least, okay, if any prime number, let's say x is the prime number just below n plus 1 by 2. So you can make a construction of 1 and then 2x minus 1, 2, 2x minus 2, 3, 2x minus 3. You can make this construction up till x, and then after that you have started adding from 2x minus 1. So from 2x to n, you can add after that. After that, you can add 2x, 2x plus 1 up till 2n. Okay. So this particular permutation that you created here, how many prime numbers would it have? How, like, at least how many prime averages would it have? Here you would have, here you would have, here you would have, here you would have. So 1, 2, 3, 4 up till x. So there would be at least x numbers, at least x indices where ci is prime. So if this x is greater than equal to n by 3 minus 1, your job is done with this particular construction. So if you can find a prime number in the range from n by 3 minus 1 to 2n plus 1. So n by 3 minus 1 to 2n, sorry, n plus 1 by 2. if in this range, if you can find a prime number, then if you can find a prime number x in this range, then through this construction you would get x indices where you have a prime number in your average array. So your problem is solved. But the only question here is, would you always be able to find a prime number in this range? Okay, so the answer is yes. Whatever n you take, you would always find at least one prime number in this range. Why I'm telling that? Like for bigger n's, not for n equal to 2, 3, 4, 5, like for them already we proved that like there is no requirement only. Okay, but after n equal to 6 and above, you would surely find at least one prime number in this range. What is the proof for that? The first thing is, if you know a little bit about some number theory and all, then you know that between any two prime number, the largest gap, so for even for n up till something like 10 to the power 8 or 9, you can maybe read the exact what are the value. For maybe something like n up till 10 to the power 8, the largest prime gap is approx 300. So even if you go to a range of up till 10 to the power 7, 10 to the power 8 like that, still between any two prime number, the largest gap would be 300, not more than that. So actually, if you just look at the numbers, then any two prime numbers are separated by very less distance. There is not too much distance between any two prime numbers. So this distance, so for some bigger n by 3 minus 1 to n plus 1 by 2, this is a huge distance. This is definitely like this 300 is for n very big n, 10 to the power 7, 10 to the power 8. For lower n, like 10 to the power 3, 10 to the power 4, this 300 would also reduce to like 100 or 50 like this. These would be the maximum prime gaps. So actually the gap between two prime numbers is so less that if you search in this range, you would definitely find at least one prime number. So this is a little bit intuitive proof. I don't have an exact proof currently. Maybe I would, if I find the exact proof for that, I'll link it somewhere in the comments. But there, this property is present there. Maybe you can search in Google and find that for some 10 to the power 7 or 10 to the power 8 range, the maximum prime gap is only 300. And for lower numbers, it would be even lower. So this was like a information that you should, if you are knowing that the gap between two prime numbers is really less, then you can solve this problem very easily. That just find any prime number in this range and using that prime number x, do this construction to form your required answer. Okay, I hope it's clear. Is there any doubts in this? We'll move on to the code now. Okay, so what I did is I took x is equal to n by 3 minus 1, and first, if my requirement, this is my required, n by 3 minus 1 is the minimum requirement for me. If my requirement is less than equal to x, like I saw for n equal to 2 up till 5, there was no requirement. For n equal to 6 was the first place where I had some requirement. So for these small values of n where the requirement is only 0, just you can print any permutation. So I just printed any from 1 to n in sequence. I just printed 1, 2, 3, 4. Okay, like you can see for my output, I just printed 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. So for smaller n, it doesn't matter. There is no requirement. You can print any permutation and return out. Okay. The main problem was for bigger n. So what I did is I took a vector of answer where I would store my permutation. Then I started searching from in this range. Initially, my x is assigned this. I would search in the range from x up till n plus 1 by 2. So I search in the range from x up till n by 2 plus 1. So n plus 1 by 2 you write, or n by 2 you write. Approximately they are the same. You would anyways find not just one prime, many prime numbers. So it doesn't matter. So I search from x up till n by 2. If this I is not equal to 1, and okay, initially I run a sieve here. So I have run a sieve here to find all the prime numbers. Okay, in this I have calculated the SPF. So if SPF I is equal to I, it means it's a prime. So I have run a sieve to just check whether a number is prime or not. So if this I is a prime number, that means I got such an value which is a prime number. I'll just do my construction and that is my final answer. My job is done. So I'll do the construction. What is the construction that I did? 1 comma 2x minus 1, 2 comma 2x minus 2. So I run a loop for j from 1 to I, and in my answer I would push j and 2i minus j. Okay, so this would be j and 2i minus j. Okay, and at the end where my j and 2i minus j, if both of them are equal, then I'll just print that only j, and if they are unequal, then both of them. Okay, so like depending on whether x is odd or even, finally I may get two numbers here, x comma, let's say x minus 1 comma x, something like that. I may get two numbers here. Basically I won't get x minus 1 and x plus 1. I may get two numbers here, and then at the end I would always get an x. Okay, yeah, I would always get a single x here after x minus 1 and x plus 1. So when my j is equal to x, or here my x is I in my code, so when my j is equal to I, then I won't push again 2i minus I would be I only. Okay, so I won't push 2 times x. Okay, so I'll push this 2i minus j only for all cases where I is not equal to j. For the last case, there would be only x, nothing, 2i minus x. Okay, so this way I made this construction, and then after that for the remaining from 2x up till n, from 2x up till not 2n, it's n, from 2x up till n, I just in sequence I just take all the values from 2i up till n. I push back into my answer array, and I just print my answer array. Okay, I've used cout answer because I have already here I have defined my output stream for a vector. Okay, so I have already defined my output stream for a vector. You can just run a loop and print this vector. Okay, this is a vector, you should run a loop and print this vector, but I've already overloaded my cout to print a vector directly in my template. That's why I'm directly writing here cout answer, but you should run a loop and write cout answer I. Okay, so my answer is printed and I return out, my job is done. So this code is accepted. That means I always find this one particular I, which is a prime number, and for which is giving me a right answer. Okay, if there was a case when I don't find anything, any prime number in this range, then I would just come out of the loop with empty, nothing printed. Okay, but this code is accepted, so you would always get it. Okay. Okay, I think this is clear. Is there any doubts in this problem? Then we'll move on to the next problem. Abhi, for your question, like there is nothing as such that this much rating is sufficient for any round. It's just you can assume the OLTs are just like another contest, and with whoever is able to solve more. You have to just improve. They don't think like that some rating is required for that. Okay, so I won't answer for that. And obviously the placement and all that is completely different, a little different from CP. Okay, is there any doubts in this problem? So I think we can move on to the next problem. Okay, E1, which is Canteen easy version. So we are only going to solve the easy version of this problem, and we would also solve the easy version of the next F1 problem. Okay, so let's look at this problem. So arcade has two sequences, A from 0 to n minus 1 and B from 0 to n minus 1. So two arrays A and B. It is guaranteed that the sum of all elements in A does not exceed the sum of elements in B. Initially, arcade can make exactly k changes to the sequence A, it is guaranteed that k does not exceed the sum A. In each change, choose an integer I such that AI is greater than 0 and perform AI as AI minus. Okay, let's ignore this because for the easy version, your k is 0. So let's just ignore this statement. Then ACRED will perform the following three operations sequentially on A and B, which constitute one round. Okay, so basically you have two arrays A and B, and in that array, these operations are performed. For all indices from 1 to n, from 0 to n, all the indices, T is the minimum among AI and BI. Reduce AI by T and BI by T. Basically, from both AI and BI, you remove the minimum among AI and BI that gets subtracted. And then your C is equal to A of I minus 1 mod n, AI equal to CI. That just means you are cyclically shifting your array to the right. Okay, so your CI would have A I minus 1. Okay, so when that A is converted to that C, that means you are just cyclically shifting your array A to the right. Okay, so these two operations just means you shift your array A to the right. Okay, the last elements comes to the first and all the remaining elements move one place to the right. That's what is happening. After that, again these operations get repeated. You want to know the minimum number of rounds required for all elements to in A to become 0 after exactly k changes to A. Okay, so let's ignore this again. It's for harder version. However, this seems a bit complicated, so please help me. Okay, so the problem is basically that, let's take this test case. You have an array A and an array B. Okay, so you have to perform some rounds of operation. You need to determine after how many rounds your array A becomes all 0 0 0 0. Okay, so let's see how the operations are performed. In round one, what would happen? For every index, you take the minimum among the two and subtract it from both the values. So minimum among 1 and 4 is 1. So you subtract 1 from array A and 1 from array B. So in your array A, 1 gets subtracted, you have 0. And in your array B, 1 gets subtracted, you have 3. Okay, minimum among 2 and 3 is 2. So you subtract 2 from it. So it becomes 0 and 1. Minimum among 3 and 2 is again 2. Subtract 2, it becomes 1 and 0. Minimum among 4 and 1 is 1. Subtract 1, it becomes 3 and 0. Okay, so this is after first operation. And then next operation is take an array C where uh, Ci is equal to AI minus 1 mod n. Basically, your array C would be, the first index would be this one, it would be 3. Next index would be this one, 0. Next index would be this one, 0, then 1, then 1. So, and then this convert this C to A. So basically, you just cyclically shifted this array A to the right. Okay, all these positions shifted by one place and this 3 moved here. Okay, this is what is happening here. So basically, this is what your array A changes to. Your array A becomes array C now, 3 0 0 1. So this is after round 1. So after round 1, your array A is still, some values are non-zero. So what happens in round 2? Again, the same thing. Among these, minimum is 3, so subtract 3. So array A becomes 0 in the first place, 0 0. Minimum is 0, subtract 0, so no change. Minimum is 0, subtract 0, no change. Minimum is 0, subtract 0, no change. Okay, so this is what your array becomes of. So after that, again a cyclic shift, this one comes at the front and all of them move to the right. So basically this one would come here and zeros would move to the right. Effectively, this would be your array after round 2. Okay, then again in round 3, minimum is 0, no change. Minimum is 0, no change. 0, no change. 0, no change. So basically there won't be any change in first operation. After that, you again shift it cyclically. So your array A would become, this 0 would come in the front and all of them would get shifted, and B would remain as it is. So this is your array B after round 3. Then round 4, what you would do, minimum is 0, don't do anything. Minimum is 1 here, subtract 1, it becomes 0 0. Minimum is 0, don't do anything. 0, don't do anything. Okay, so after this operation you got 0 0 0. You shift it cyclically, it remains the same. You got all zeros in this array after 4 rounds of operation. So your answer for this test case was 4. Okay, you can see for this second test case we took, our answer was 4. Okay, I hope what you need to do in the problem, that is clear. Now how do you do this efficiently? If you do the brute approach, for every round take the minimum and do it. So just simulating every round would take order of n time, and you have to, at max it would take n rounds to do it. So it would go order of n square overall, which won't be accepted because the constraints are n is 2e5. Okay, so you need to optimize this thing a little bit. How can you optimize this is, if you look what is happening here, just try to understand what is happening actually. Okay, so if you look at this, at the array A, you have A1, A2, A3. Let's say these are some values. And then you have array B, B1, B2, B3, B4, B5, B6, like that. Now let's try to look what is happening to every, after how much time every value is going to become 0. Okay, so what is happening in the first round? We take just, if this array, if this B1 is greater than A1, then what would happen? This, if this A1 is the smaller number, it would become 0. And if this B1 was the smaller number, then A1 would get reduced by B1. That's what is happening in the first round. So either it would become 0 or A1 minus B1. So among them, if A1 minus B1 is negative, then it would become 0, that you can say. For A2 also, either it would become 0 or A2 minus B2. Okay, so likewise, first of all, it would happen. After that, if for those values which remained non-zero, how, when would they become 0? So initially this was the matching through which you were using the subtraction thing. After that it would get cyclically shifted. So this A1 would come here, A2 would come here. So in the next round these two would be compared. Okay, if among these two, if there is, this A value is smaller than whatever is there in this, then it would become 0. Otherwise it would reduce by this value, and again try to search for this in the next round. So until this A1 becomes 0, it would move round by round. Now let's try to calculate how many rounds it would take for any index I to become 0. Let's say we have some A2. Let's say we have some AI. Okay, for now I'm taking A2. I want to make this 0. What would be my cases? Let's try to look. First case is if already this B2 is greater than A2. So if B2 is already greater than or even equal to A2, then A2 would become 0 in the first round only. So it would only take one round to become 0. Else, okay, if this is not the case, in the else case, so one thing is, if B2 is greater than A2, my answer is 1. For this index, it only takes one round. Okay, if not, then this A2 would become A2 minus B2. Okay, first of all, this A2 would change to A2 minus B2. Okay, and what would happen in the next round? This would be compared with this. Now this B3 would also have changed from the first round. How would that B3 change? If again there would be two cases here, so let's look at those two cases above. If A3 is greater than B3, greater than or equal to B3, then this B3 would become 0 after the first round, then B3 would be 0. And if A3 is less than B3, then B3 would become B3 minus A3. Okay. So these are the two cases for B3. Now here I would compare this with this B3, either this or this. Okay, let's see in this case. If A3 was less than B3, then we compare these two values. Okay, we compare these two values. If this value is smaller than this, then it became 0. Otherwise, it would get reduced by this value. So if again for the else case, so like here, what is my condition? If this A2 minus, okay, so my condition here is, I can write, if this value is less than this value, then my answer would be 2. In second round only it would become 0. So if A2 minus B2 is less than B3 minus B3, then it's okay. So if you bring it this side, it's actually A2 plus A3 minus B2 plus B3 is less than 0, or you can say this, yeah, is less than 0 is my condition. So this you can say is the condition for this case for my answer to be 2. And if it is this case where my B3 is 0, then if my B3 is 0, then A2 minus B2, with this 0 it would never become 0. So in this case I can never have my answer. But if you keep this same condition, then this would actually be negative. Okay, for this case, my B3 minus A3, if you keep it here B3 minus A3 only, it would be negative. So if you just add basically from A2 minus A3, you were subtracting this. So subtracting a negative value is actually adding it. So you know for sure this minus this, if this was positive, okay, so if this thing was positive and this thing is negative, so this minus this, what we did here, this minus this is what we did here, this would remain positive only. So checking this only condition that whether it is less than 0 is sufficient for both the cases. That's what I'm trying to say. Even for this case where my B3 is already 0, if in that I add this negative number, it would increase my value only. It would not make it below 0. So for this case, we know we cannot make, if my B3 is 0, we cannot make my A2 0 using 0. So my answer would anyways would not be 2. So my answer can be 2 only if this thing is less than 0. So checking only for this condition is sufficient here. That's what I'm trying to say for both of these cases. For both of these cases, only checking this condition is sufficient if you want to make your answer 2. So here I would write that if A2 plus A3 minus B2 plus B3, if this thing is less than 0, less than or equal to 0, even equal to 0 is okay, it would make it 0, then your answer is going to 2. Same, this condition I can just rewrite it as, okay, this condition can be rewritten as A2 minus B2 less than equal to 0. These two are the same thing. Okay, so I'm writing that here instead of writing that. Okay, so our first condition was if A2 minus B2 is less than 0, my answer is 1. In one round it would be done. If A2 plus A3 minus B2 plus B3 is less than 0, my answer is 2. Else, again, if you go to else, if this doesn't satisfy a condition, then it would be compared with this. What would be my A2 now? This A2 would get reduced by this value. Okay, so my A2 is now changed to, it was A2 minus B2, now it got reduced by this value, so minus B3 minus A3. So it is actually A2 plus A3 minus B2 plus B3. Okay, that was this subtracted by this. This is my A2 now. Okay, so this is changed to my A2 is this now. Now I would compare this thing with before, my current before, after 2 rounds. Okay, so again, what would happen to this before after 2 rounds? After the first round, this before would get reduced by A4. It would become, after first round, this before would become B4 minus A4. After the next round, it would get reduced by this A3, and this A3 was already reduced by B3. This A3 was already A3 minus B3, so it get reduced by A3 minus B3. So actually it is B3 plus B4 minus A3 plus A4. So that's what my effective B4 is, and I need to check this effective B4 with A2. So I have to subtract these two values, okay, to check again. So if this minus this becomes less than equal to 0, then again my answer is 3. So what is this thing minus this thing? It's actually A2 plus A3, and minus plus this would get added. So plus, I won't have 2 times A3, I would have slight mistake I think there. What would this B4 would be effectively? Initially it got changed to B4 minus A4, and after the next round it got compared to A3, so this got reduced by A3 minus B3. um, this is 0, then okay. Okay, yep. So this would become B3 plus B4 minus A3 plus A4, and here my effective A2 is, this A2 got reduced by B2, so it was A2 minus B2, and then it got reduced by the effective B3, which made it this thing, and then these two would be compared. So you would like eventually get, I think you can understand from the pattern, eventually you would get this pattern only. Your condition would be A2 plus A3 plus A4 minus B2 plus B3 plus B4. So if this thing is less than equal to 0, then your answer would be 3. Okay, like you can, for the second one it was easy to analyze, just 2-3 cases only, but for 3 numbers it becomes a little complicated. Maybe you can analyze one by one, case by case, but from the pattern recognition only you can get that eventually you are going to get this pattern only. This would be the condition, that if the sum from 2 up till 4 for A minus the summation from 2 up till 4 for B, if this thing becomes less than equal to 0, then in the third round you are going to make it. So same it would continue likewise. If you want to, if your answer should be I, then you should have A2 plus up till AI minus, if this is less than equal to 0, then you would say that your answer is I. Sorry, 2 plus I. Okay. 2 plus I minus 1. If I'm starting with A1, if I'm taking a 0 based indexing, it would be 2 plus I only. Okay, so that plus 1 minus 1 you can understand. So I hope you got what I'm trying to say. Is just to, if you want to check for any value, okay, if you have the two arrays, if you want to check for any value I, that after how many rounds this would become 0, then it would be either if this difference is negative or less than equal to 0, or this sum minus this sum. If that is less than equal to 0, then after, if this is less than equal to 0, then one round. If not, then if this sum minus this sum is less than equal to 0, then two rounds. If not, then the three elements minus three elements, if that sum is less than equal to 0, then three rounds. Okay, so basically what you can do is you can form a new vector v which would store ai minus bi. Okay, that's what you have to do. You have to keep adding ai minus bi, ai plus 1 minus bi. So you are adding this and subtracting this. So whatever is the difference of ai minus bi, if you keep another vector where vi is this ai minus bi, so basically you would say if your summation from v, if your sum of, so for the ith index, your answer for the ith index would be that how many rounds it would take would be the first j such that in the vector v, whatever is the sum from I up till I plus, if this sum becomes less than equal to j, the first index j, the first j such that the sum from I up till I plus j becomes less than equal to 0, then your answer is j. Okay, so in mathematical form that we can say, if your initial, if this sum only ai minus bi only becomes less than 0, answer is 1. If ai plus 1, okay, so in vector v you would have vi and vi plus 1. Okay, vi is this difference, vi plus 1 is difference. So if the sum of these two values become less than equal to 0, your answer is 2. If sum of these three values becomes less than equal to 0, your answer is 3. Okay, so this way, if you calculate it for all indexes, if you calculate for all indexes, the first point where my sum is starting from that, where my sum becomes less than 0, then the maximum among all the indices is going to be my final answer. Like for, if you calculate your answer for all the indices, that this ai becomes 0 after some x I seconds, this ai becomes 0 in some x I plus 1 seconds. So whatever is the maximum time, that maximum among them would be the time after which all the ai becomes 0. Okay, so how do we now compute it optimally? Like if you just one by one sum it up and try to check when it would become less than 0, that would take again order of n square. But you can do it faster using a prefix sum. So you like you, if you try to look it using a prefix sum. So once we have created this vector v, what is my sum from I up till I plus j? If I have pre-computed my prefix sum array, then it is prefix I plus j minus prefix I minus 1. Okay, that is what my sum from I up till I plus j is. So basically, if you look at the prefix array, then and my condition is this should be less than equal to 0. So for any index I, the first occurrence of an index where my this becomes, okay, so this condition is this prefix I plus j would be less than equal to prefix I minus 1. Okay, so the from I up till n, the first index where my prefix sum becomes less than this value, that that index gives me my answer. So this can be easily done, like if you try to think, okay, let's say I'm representing this prefix sum. For I equal to 0, you start with a sum of 0. Okay, then for I equal to 1, you get some prefix sum. Okay, let's say it increase, then it may decrease, then it may increase, increase, decrease, 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 increase, decrease, decrease. Okay, so that's how your prefix sum curve moves. Okay, as with the value of vi, it may increase, decrease, increase, decrease. So for any index I, if let's say I want to calculate my answer for this index I, then I can say, if I have to calculate for this index I would look at I minus 1, the first value where my sum goes below this. Okay, the first j where my sum goes below this or less than equal to this, that j would give me my answer. The distance from that j from I would give me my answer. So how can you compute this? That you can use a stack, and when you, like, once you have computed your prefix sum, push this into your stack. When you are increasing, just keep pushing in your stack. When you decrease, then this is your answer for all the values where you were above. So for this, your answer would be this. For this, your answer is this. For this, your the next value just below it was this. So answer would be this. So in your stack, just keep pushing the values, and whenever you're, when, like, in your stack you pushed this value, then you push this value. When you went to this value, you check that the top of your stack is greater than this. So you would say that the answer for this one would be this. Okay. So for any I, your answer is the next smaller element. Okay. Basically, for any index I, your answer would be whichever is the next smaller, uh, whichever index stores the next smaller value. So the algorithm to calculate the next smaller, previous, greater, these all is through a monotonic stack. You can maintain a monotonic stack. Okay, keep pushing the values until they are greater. When you get a value which is lower than the top of the stack, then pop these values and say that your answer for this is the distance between these two. Okay, and then push it. Now these two are in the stack, greater value, push. Then when you get a smaller values, pop all the elements greater than equal to this, and for them answer is this distance. Okay, then again when you get a smaller value, pop all the values which were greater than equal to this, and this distance is your answer. Okay, same way this distance is your answer, keep popping. Okay, so you just need to find the next smaller element for every index I in your prefix sum array. Okay, so first convert this array into an array new vector which would store ai minus bi, and then take the prefix sum of that vector. Okay, so pr is the prefix sum of v. Okay, where v is ai minus bi. Okay, so take the prefix sum of ai minus bi, and in this prefix sum array for every index, find out the next smaller index, and the distance between j and I would give you the answer for ith index. So maximize that answer for all the indexes, you will get your answer. Now you have to do this cyclically, because from 0 to n you have the array. For any index I, you may go even after n you have to reach 0. So what you can do is, instead of considering a single array, you can join this same array again ahead. Okay, so make an array of 2n size. The first n indices same as the array, next n indices repeat this array again. So for this, after n minus 1, you have to went back to 0. So you got 0 after that, you got 1 after that. So whenever you have to do something cyclically, you can use this uh, thing, that you can merge the same array 2 times. That way, whenever you take the prefix sum of this thing, just you can do everything assuming this is a linear array only, and you will achieve what you can do using a cyclic array. Because in a cyclic array, after n minus 1 you get 0. So here also after n minus 1 you got 0. So same way you can just do everything here. So I hope this logic is clear to you. we can move on to the code now. If there is any doubt, please ask in the chat. Okay, so what I'm doing here is I take the input array A and B. After that, I create this vector v. This is basically my prefix sum array where I would add the prefix sum, and this is of size 2n. As I said, I'm just merging these two arrays two times. Okay, so I take this vector of size 2n. Initially, it would be initialized with a0 minus b0. After that, I take the prefix sum. Vec I is vec I minus 1 plus what is my current value? My current value is ai minus bi. And since I'm taking a cyclic array, so for at index n, it should store index 0. At index n plus 1, it should store index 1. So if I take n modulo n, would give me 0, n plus 1 modulo n would give me 1. So I have to just take mod n. So I mod n would give me the value that should be stored at index I. So I just subtract ai mod n minus bi mod n to get that value. I take the prefix sum. So in vec I have this. So this vec is actually my prefix sum array. So in that prefix sum array, I have to just apply my stack to get the next smaller element. So in my monotonic stack, I initialize monotonic stack with stack of pair of int comma int. This is actually pair of int comma int. Okay. So I initialize a stack of pair. Then I just keep pushing in. I just check if the top of the stack is greater than equal to vec I. Then I pop the stack and maximize my answer for the distance between the two. Okay, so stack in my pair in dot second, I'm storing the index. In dot first, I'm storing the value. Okay, so this way I'm pushing my into my stack vec I comma I. So vec I is the value which I would compare whether it is greater than vec I or not, and I is the index through which I would take the distance. Okay, so this way through my monotonic stack, I'm just maximizing my answer for all the index and printing it. Okay, so I hope this logic is clear to you. What would be my time complexity? This input part is taking order of n time. This prefix sum pre-computation is taking order of n time, and this again, there is a while loop, but at max in this stack, I would push n times and pop n times. So overall, this would run 2n times only. So it would be order of n only. So my overall time complexity is order of n, and my overall space complexity is, I have two vectors of size n, and this vec is also size 2n. So order of n only. Okay, I hope this problem is clear to you. Can we move on to the next problem? Okay. So final problem for today, which is F1. So there is a whole lot of story written here. So I'll explain you what the question is directly. So you are given n, l, and k, and this k has no meaning in the easier version. It is 0 in the easier version. So I'm just going to ignore this k for the easier version. So basically you are given two things, n and l. So what you need to find out is, it's like this. You have l locks. Okay. So you have some l locks. Okay. And there are l keys. So there are l locks and there are l keys. So every key corresponds to a single lock. Okay. But you don't know which key corresponds to which lock. So you are going to try and match those keys with the locks. Okay. So there are n people. One by one, every person would take turn. Okay, so starting with person number 0 up till person number n minus 1. Then again after person number n minus 1, person number 0 would take turn, and it would keep on repeating like that. So this way each person takes the turn. In his turn, what he would do is, among the remaining keys and the remaining locks, he would select one key and one lock and try to unlock it. If he is able to unlock it, you get the conclusion that this key belongs to this lock. You found a match. If he is not able to unlock it, then you found that this is a mismatch. Now that person would pick such a key so that there is maximum probability that he can find a match. Initially, the probability of finding a match is equally likely for all the keys and all the locks. Okay. After every step, whether on the basis of the results that you found a match or not found a match, you would try to select such a key and lock pair so that there is maximum probability to find a match. And then that way it would keep on you would keep on doing that until all the L matches are found. Okay, until all the L matches you have found, you would keep on doing this. After all the L matches you have found, finally you need to answer that for each person, what is the expected number of matches that he finds. That the person number of 0, let's say in the first iteration he found a match, next iteration he didn't found a match, likewise. So according to the probability, what is the expected number of matches that the ith person finds, you have to answer for all the n people. Okay, and here n is given as less than equal to 100, L is given less than equal to 5000. You have to solve with these constraints. So I hope the problem is clear to you, what you need to do. You can read it if it's not clear. I'll move on to the solution part, what you need to do. So basically, if you look what is happening for the first person, for the first move, what would be your probability to find a match? Since all the locks are the same, all the keys are the same. Okay, so there are total L locks and L keys, all of them are same. So you would select one among the L locks. So there are L choices to select a lock and L choices to select a key. So there are L square choice, total different choices that you can make when you select a lock and a key pair. Out of them, there are L pairs that are correct, that are valid matches. So what is the probability that you get a valid match is L divided by L plus L. Okay, I hope you can understand. So this is 1 by L. So initially, if there are L locks and L keys, there is 1 by L probability that you would find a match if you just select randomly any lock and randomly any key. So for the first iteration, it would be 1 by L probability to find a match. Okay. Then for the next iteration, what it would be? So there can be two cases. Either in the first iteration, the person found a match, or in the first iteration, the person didn't found a match. So for the 0th person, this was the case. For the first person, if the person one found a match, okay, let's say a person one found a match, then you would remove these two from your, because already you know this lock and this key are matched, so you would remove them. So there are a total of, you reach back to the same condition where there are L minus 1 locks and L minus 1 keys remaining with you, and you just have no other information apart from that. So there would be again 1 by L minus 1 probability to find a match. So for the case where you found a match, so there was 1 by L probability that you found a match in the first case and 1 by L minus 1 probability to find a match here. And there was L minus 1 by L probability that you didn't found a match in the first case. Now, if you didn't found a match in the first case, okay, so let's say you tried these two and you didn't found a match, then what would the second person try? Now he knows for this lock, this is not the key. So he would select this lock and select any one of the remaining L minus 1 keys. Okay. He knows this is not the key. So selecting this, for all the other locks, there are L choices. But for this lock, there are only L minus 1 choices. So this would be the most best case scenario for him, where he has the maximum probability to find a match, that there are only L minus 1 choices. So again, there would be 1 by L minus 1 probability for him to find a match in this case as well. So in both the cases, whether first person found a match or not, he would have 1 by L minus 1 probability. This way you can keep on calculating, but from the third person the things would become a little complex. So this was the first thought for the way to calculate, but if you keep calculating like this for the third and fourth person, things would become complex. You won't be calculate able to calculate something and maybe form some DP state. So what is the thing to observe here is, instead of looking for every step, that whether in step 1 would you find a match or not, in step 2 would you find a match or not, look it like this, that what is the probability that this ith person finds the ith jth match. Okay, so I would take a DP state like this, where DP xi represents that ith probability that it would be the probability for the ith person to find xth match. Okay, now how would I compute this? So why I have taken this state, you will understand now. That what this my state is that okay, before coming to the state, let's like you would understand now why I'm taking this state. Let's say in some ith round, you found this xth match. Okay, or let's say here only in, let's understand it simply, then we would understand in terms of variables. In the first case, let's say you found the first match. There was 1/L probability, but whatever was the probability, you found a match. Whenever you find a match, after that for the next person, what is the probability to find a match? If you found a match here, then for the remaining number of logs, you don't have any information, because it would always happen like this. If the first person found a match, okay, if the first person didn't found a match, then you would keep the same log and try for the remaining keys. Let's say the second person again didn't found a match, then the third person would try in the remaining L minus 2 keys. If he again didn't found a match, he would try in the remaining L minus 3 keys, the remaining person. And then let's say if he found a match, then his probability to find a match would be 1/L minus 4 here, if 3 matches were already not found. But once he found a match, all these 3 information that this key doesn't belong to it becomes irrelevant now, because you know that this log belongs to this key and you have already removed this log. So for these key, now this log is removed. If you found the second match here, then you have L minus 2 logs remaining, L minus 2 keys remaining, which are unmatched, all of them as the same state. So again, you come back to the same state. So whenever you find a match, after that you come back to the same state, that for the next person, your probability to find a match is L minus X, if you have already found X matches. Okay, so if you have already found X matches, the probability for the next person to find a match would be 1/L minus X. So you need to move like this, that what is the probability that I find the xth match, then I find the x plus 1th match, then I find the x plus 2th match. So if you move like this, then one more observation to note here is, let's say you found a match in the first, okay, in the first case you found a match. Okay, I'll write more neatly here. You had these L locks and these L keys. Let's say in the first match you found a match, like in the first case you found a match. So for the first person, it was 1/L probability to find a match. Now the second person, he tried with one random lock with another key, and he didn't found a match. So the second person didn't found a match. What was the probability for him to not find a match? As I told initially, that after you found a match, then your probability to find a match was remaining number of keys, so 1 by L minus 1. So 1 by L minus 1 was probability to find a match. So here I'm telling that he didn't found a match. The second person didn't found a match. So probability for it would be 1 minus 1 by L minus 1, okay, which is actually L minus 2 by L minus 1. This is the probability that he didn't find a match. Let's say the next person, now the next person knows that this key doesn't belong to this lock. So for this lock, he has only L minus 2 options to check. So if he checks in this, probability to find a match is 1 by L minus 2. Let's say this third person also couldn't find a match. So what is the probability that this third person couldn't find a match is, this was the probability to find a match. So probability to not find a match would be L minus 3 by L minus 2. And let's say after this, the fourth person was the one who found a match. So what was his probability to find a match is, since you know for this lock, these two keys are not there. So you have L minus 3 keys available. So probability for him to find a match was 1 by L minus 3. So here you would write, if this fourth person found a match, its probability is 1 by L minus 3. Now, after this, after the first person found a match, this fourth person was the next person to find a match. Now, what is the probability that exactly after this, okay, once this is done, let's remove that. Once this is done, if I am left with L minus 1 locks and L minus 1 keys, what is the probability that this fourth person is going to find the next match? It would only happen if this person doesn't find a match, this person doesn't find a match, and this person finds a match. So my total probabilities for this person to not find a match is this, for this person to not find a match is this, for this person to find a match is this. So overall we would just multiply all of them, and if you multiply this, what you get is 1 by L minus 1. So actually for the fourth person to find a match, okay, when there are L minus 1 locks and L minus 1 keys remaining, then for that the next match would be found by the fourth person, the probability of that is 1 by L minus 1. Okay, now let's try to find what was the probability that fifth person finds the next match, not fourth. Then you would say that this fourth person doesn't find a match. If this fourth person doesn't find a match, this probability would be L minus 4 by L minus 3. And if this fifth person finds a match, this probability would be 1 by L minus 4. So again, you get this and this got cut, this and this got cut, and you multiply by that, this and this got cut. What you got is 1 by L minus 1. So after you found a match for the first person, now for the state where there are L minus 1 locks and L minus 1 keys, for this person to find a match, the probability was 1 by L minus 1. For this person to find the next match, I'm not talking whether this person finds a match or not. I'm talking this person finds the next match. After the first match, this person finds the second match. Would only happen if he doesn't find and he finds. Its probability is also L minus 1 by L minus 1. The probability that this fourth person finds the next match and not these is also 1 by L minus 1. Probability that fifth person finds a match and not any of these is also 1 by L minus 1. So basically, if you see that if some ith person finds the xth match, let's say the ith person finds the xth match, then for all the next I plus 1th person, I plus 2th person, up till what? So for all these person to find the x plus 1th match, probability to find the x plus 1th match would be 1 upon L minus x. Now probability that I plus 1th person finds the x plus 1th match is 1 by L minus x. Probability that I plus 2th person finds the x plus 1th match is also 1 by L minus 1. For I plus 3 also it is 1 by L minus x, as I had proved from here. Until where? Like till where it would happen that nobody finds a match. This series keeps on repeating that nobody finds a match. So if there are L minus 1 keys remaining, L minus 1 logs and L minus 1 keys, then after, let's say all these L minus 2 people don't find a match, then for this last person there's only one key available, he would definitely find a match. So there is one probability for him to find a match. So basically for all the next L minus 1 people, there is 1 by L minus 1 probability to find a match. After the L minus 1th person, the next, if it is I, that for the I plus Lth person, for him you won't add this 1 by L minus 1 probability, because this, if you found the xth match, okay, if ith person found the xth match, then all the next L minus x people would have a probability of 1 by L minus x each to find the x plus 1th match. Okay, this, if we're not able to understand till where you would have, then this clearly gives you an idea that for finding the xth match, for finding the x plus 1th match, if I plus 1th person finds that match, probability is this. I plus 2th person finds the match, probability is this, until I plus L minus xth person. This person would also have a probability of 1 by L minus x. For all the remaining people, their probability to find a match, x plus 1th match, would be 0. Okay. So basically, now you can understand why I was taking this DP state. DPXI, where probability for the ith person to find the xth match is what my DP state. And what would be my transition? Here you can understand the transition, that for this person to find the x plus 1th match, the xth match should be either with this person or with this person. Okay, then from there you would add plus L minus x, or with I minus 2th person. So basically, if you want to turn backward and write this, then you can say that your dp of xi, what is the probability that ith person finds the xth match, would be the summation of dp. Okay, what was the probability to find the x minus 1th match? Okay, so this was for x plus 1th match. I'm writing for x. So here, this you can assume as x, this you can assume as x minus 1, that way. So I'm writing the pull dp, basically what all would constitute this dpi. Okay, so in order to find the xth match by the ith person, the x minus 1th match should be found by the jth person. Whatever is the probability that x minus 1th match is found by the jth person, that multiplied by that divided by L minus, here this x is replaced by x minus 1, L minus x minus 1. Okay, so basically summation of this, okay, you can take this summation, and this whole, like for every value you would divide by this. So this is your dp transition basically. And till where would you j go? J would go from I minus 1 up till I minus L minus x. Okay, something like that. Plus 1 minus 1 you can just calculate while writing the code. So for all the previous L minus X values, if any of them, at any of them you find the X minus 1th match, then from that you would say that there is L minus X probability that this jth person would find the Xth match. So this I hope you understand. So this is pull DP type. You can write a push DP type where it would just reflect the same thing as I denoted here. That if you are at I comma X, then you would just update all the values from I plus 1 to I plus L minus X. In all those values, you will add dp of x plus 1, and this you would add 1 by L minus X. This much probability would be this multiplied by whatever is the current probability. Okay, so this would be the probability to find this after it has already happened. So probability of this happening multiplied by this would give you the overall probability of that event happening. Okay, so you have to multiply by that dp. So what would be the complexity of this? Now this dp states this x would vary for n. Okay, n is around 100, at max 100. So sorry, this x would vary up till there can be L matches, na? So this would vary for L, which can be up till 5,000, and this I would vary from 0 to n. Okay, so the people are, there are n people which are at max 100. Now here you have to vary this j from I minus 1 up till this. So this can go negative. So if it is going negative, you have to basically do it in a cyclic manner and repeat this. So for any ith person, all the remaining L minus X values, it may happen that n is this much only. So this complete array would be repeated many times. So you would just check for every index how many times that index is coming in the last L minus X value. So that many times you can add your DP. So basically you only need to check for the n people. For the n people, for every ith people, you can just calculate that how many times this index is going to occur in this range. Okay, so you have to consider this as a repeating cyclic array. So this way, this overall is going to take at max order of n only. So order of n is my transition and order of L into n is my states. So overall would be order of L into n square, which would be 5,000 into n square is 10 to the power 4. So 5e7 would be well accepted. Okay, so I hope this logic is clear to you. We'll move on to the code quickly. Okay, so what I'm doing here is I'm taking my dp, which is L cross n. Initially for the first, what is the probability that who all are going to get the first match? So the first L people have a probability of 1 by L to get the first match. So the first L people, I'm running from 0 to L, and I'm taking I mod n. So if I'm going above n, do mod n and repeat it cyclically. So dp of finding the first match for the ith person is going to increase by 1 by L. Okay, so I've already calculated the inverse modulo. I would need the modulo inverse from up till only the range of L. Range of L was 5e3, I've taken till 1e4. So I've pre-computed those modulo inverse so that I don't have this extra log n complexity factor included. So I pre-computed those modulo inverse and I add the modulo inverse of 1 by L and take mod m. Okay, so this is my base case. What is my transition? As I said, my transition would be for any dpxi, sum of all the values from, okay, so you had to sum like this, but you would sum like that for any index I, for all the previous L minus X values. So basically you have to run your loop till j minus L minus X plus 1. Okay, so from this index IND to j, from IND to j, all the values are going to contribute a plus dp of that. So for if any index, you can compute how many times that occurs. So in ci, from ii minus index by n, plus 1. This way you would get that how many times that index is going to come in my summation. Okay, so how many times that index is going to come in my summation, this I have calculated. So I have multiplied c multiplied by dpx minus 1I. Okay, so in my sum, this is multiplied by how many occurrences of this index j. Okay, so that I have written here. So I run a loop for all the index from 0 to n. Okay, if this index is greater than equal to j, then I would move it after cycling moving back. So I just reduce this by n. If it is less than j, then it is just towards my left. Okay, and if this I becomes less than index, then continue. There is 0 occurrence. Otherwise, there is this many occurrence of that index. So add that many times dp x minus 1I. Add that to your sum. Take sum modulo m, and your final answer would be this sum divided by L minus x plus 1. This sum into inverse of L minus x plus 1. That's for your dpxj. Okay, this way I've written my dp transitions. My final answer would be, okay, what would be my final answer? So if I've taken this dp state, xi represents the probability for the ith index to find the xth match. So my answer I is the summation of to find the first match, second match, third match, or the lth match. So dp of xi for x equal to 1 to L. Okay. So for the ith person, to find the first match up till the lth match, the sum of all the probabilities is going to be the expected number of matches that the ith person finds. So for every person, I take the sum of dpxj for all the x from 1 to L, and I print my answer. Okay, I hope this is clear to you. What would be my time complexity? This loop is taking order of L time. There is L cross N loop, and this is N loop. Okay, so this is N. So overall, this is running N times, this is running N times. So this becomes N into N, and this multiplied by L becomes L into N into N. Okay, and this is running N into L times. So overall time complexity is order of L into N square. And my space complexity would be, I'm using a dp of size L cross N. Okay, so L cross N would be my space complexity. I hope this problem is clear to you. So if there is any doubt, you can ask, or maybe we can end the session now. Okay. Thanks a lot for tuning in. Goodbye.